Hello, better? Yes, no? Somebody's still in the old chat. If you'd throw this web link into that one, up to 4. Keep going. The other one, awesome. Thank you. Thank you. Hello. Hi, hello. Welcome to my deck. This is my porch. Here you go. My yard. Hello. Children are sleeping, so we're outside. Yay, hearing. Now we just gotta make sure everybody who wants to be here comes. Cool, give it a little bit. Welcome. Hello, we're going to try this. Obviously, there's going to be some kind of learning as we go here. I was unable to go back and modify, which it defaults to no microphone, which was weird, so I apologize for that discrepancy. I'll give a couple more minutes here, and then we'll kind of get into the nitty-gritty here a little bit. But if you want, while you're waiting, behind me are the kind of important pieces for our upcoming assessment in terms of kind of the exam itself and what that's going to look like. Nice part about streaming like this is it automatically records it, so we'll be able to just push that out for anybody who is not here today. Again, I'll give them more time. Anybody remember how many people were in the old chat? Hello in TV land. I think we're all here. Everybody who was in the other one. If not, if you join us kind of midway through, as people start to join us, again, we'll be able to go back and revisit just those first couple minutes should you miss something. Yeah. Yep. All right. Cool. Sorry, somebody is awake. 1 second. Cool. So test is on board behind me. We're going to break it into 3 days. Essentially, what I'm going to do is I'm going to take kind of that first day. I'm going to split it into 2 chunks. So it'll be kind of the traditional multiple choice part, which we would have done online anyway. That's going to be the first day. And the 2 short answer that would have been that day, we're going to kind of break out and do on Thursday, just to make sure we got plenty of time. Kind of keep it balanced with your other courses to make sure that you've got plenty of time for everything. We are going to make these a little bit time sensitive. This is in an effort to minimize the chance of the spreading of information. Not that I'm worried about it. It's just, as a teacher, one of the things I got to be cognizant of. You guys are awesome. You're rocking it. It's just good to kind of talk about that piece and why I'm doing it the way I'm doing it. One of the big concerns from the practice quiz, I learned a lot from that. Thank you for helping out with that. It was also a good review for us. I'm not a big fan of how it did the short answer calculation, that it was all or nothing. Some of you will notice I went back and retroactively gave points that even if you didn't quite get the right answer, you still got points for a reasonable attempt on it. That would be just like if I were grading it on a paper version. As we were looking then at kind of the other feedback piece there, somebody had a couple different people suggest not locking one question at a time, so that way you can move ahead and then come back if you have additional questions. I'm going to make sure to have that setting so that you can move forward and make sure you're utilizing your time well in terms of that secondary assessment piece. If for some reason 11 o'clock doesn't work for you, just let me know. Got to know in advance so that we can get you kind of set up with a kind of different time period for you to be able to go back and hit that assessment piece later. Hopefully the board's flipped for you guys. On my screen, it's in reverse. Nobody's yelled at me yet, so I think we're okay. And so tomorrow, it's going to be 45 minutes, so it should be plenty of time. It's going to actually say 21 multiple choice for 40 points, but I'm actually going to, there's a little bit of built-in bonus there, and so that's why that kind of works out a little bit differently there. But it'll be 40 points coming from the multiple choice part on Wednesday. On Thursday, you're going to have 30 minutes for two short answer. If I was a betting person, I would probably anticipate some balancing of redox reactions. And there's two types. There's an acidic and there's a basic. And there's two short answer for Thursday. Nope, there won't be a password. Sorry, Olivia's question just popped up. There's no password. It's just the test will not be unlocked until right at 11. You will still need lockdown browser, but get in at 11. You'll be able to access the assessment, and then you'll have 45 minutes. 45 minutes to complete it, and then be wrapped for that first day. Mm-hmm. Great question. So two short answer on Thursday, and then Friday will be kind of that second day that we normally have kind of the more nitty-gritty written questions and or calculations. You'll have a full 45 minutes for that. 12 short answer, I say 12. A lot of them have kind of multiple parts to them. Been going back and forth on how to do the written part. I think the best way, and here's how I'm going to kind of work this. I'm actually going to make PDFs of both of these parts of the exam. And so it'll look like a test. You'll actually click on an exam. I'll probably call it Chapter 21, Part 2. When you click on there, there's going to be a document. You'll just download the document, and that is the test. You'll have 30 minutes to kind of complete it. Then just on your computer, you'll just take a snapshot. You could write it, print it if you want, or you could just write down the answers to them on a piece of scratch paper, hold that up, take a picture of it, and you'll be able to then just resubmit that back to the question. Then I'll be able to, that'll keep it organized for me, and I'll be able to go back and grade all of your work to make sure we're getting partial points and making corrections as we need to. So that's going to be how we try to run that. I'll admit this is my first assessment to try to do that. So if there's glitches there, we'll kind of make it work. You guys were awesome today. I'm going to be looping Tech in as well as Mr. McDormand, who's our AP curriculum person, because my understanding is I'm pretty sure our AP board is going to test through the AP classroom. So we got to figure this out one way or another. So thank you for everybody for your help and kind of trial and error on that. And so we'll kind of go from there. Question popped up. Will the 30 minutes count printing time? I'm not sure I understand. So you're saying within 30 minutes, do I expect you to print it, fill it out, take a picture, and resubmit it? I think is the question. Yeah, hopefully. Should be plenty of time on that. If for some reason it gets locked up and you're outside that, just email me your work, and then I'll be able to go back in and kind of retroactively slide that in. Really kind of the time restraints here is really just to make sure that we're kind of completing it within the time that we have. If for some reason you get outside that just a little bit, shoot it my way in an email. I'll get it uploaded for you. No. So the 2 days, the short answer to the question was, do we need a lockdown? No, these 2 days here, it won't let you take pictures and upload like that. So these 2 days will not be locked down. It'll just be the first day that's in lockdown. Mm-hmm. So probably the most expedient is going to be just have a notebook paper. The PDF will pop up with the test. You do your work for the problem. Just label clearly what problem number it is. Fastest way will probably be just take a picture with your computer and then just drop it back into the assessment. And if it for some reason refuses to upload, just shoot it in me in an email, and I can sort it on the back side. So, thank you. You guys have been awesome. This is very atypical. This is not how we normally run things. So continue to be awesome. Cool. Also, great job with the questions. I love that we're kind of thinking as we're going here. Cool. Questions on the format. I know this is new and different. I want to make sure everybody's feeling as comfortable as possible before we kind of move forward. Well, if you think of questions, throw them in the chat. I got it open. We're rocking it. You're great. just like our normal test review day. Just as important as being comfortable is what we need to know for the test. As you know, quizzes are a great spot to go back and spend your time kind of highlighting the important pieces from the unit. Going to need to know how to assign oxidation numbers. We kind of practice that with the very first piece of this unit because that then determined our ability to navigate all of these other topics. Need to be able to balance both in acidic or basic solutions. Should be able to determine cell potentials using our standard cell potential sheets. You will be able to access Appendix D as you're kind of working through. I believe most of them have the values provided for you, but should you need a value and for some reason it's not there, just pull out Appendix D and use that for the assessment. There's no information on there that you would not be otherwise able to access. If you remember, we had that orange pre-ag table that had cell potentials on it as well. I would have given that to you if you were in class, but we'll just use Appendix D out of our kind of handouts as we're moving forward. Voltaic versus electric, galvanic kind of mean the same thing. Those are spontaneous reactions. And so for those, we would say we have a positive E cell potential, and it is a negative free energy because we're releasing that energy freely into the world and being removed from our system. Kind of the differences, big differences in terms of kind of the setup for the two. We've got 2 half reactions for voltaic, 1 pot for electrolytic, and what happens with our electrodes. If you remember the sign switch, just to kind of indicate where the cations and anions flow. But the same changes occur at the anode. It's oxidation at the anode, reduction at the cathode, just like we saw for all of our kind of previous examples. From that, you should be able to write in cell notation, low to high to low. We practice that quite a bit. If it's an acidic, you just add the H+. If it needs some inert or passive electrode, you would just then include either graphite or platinum as a solid on that side of our cell notation. Then math. We didn't do a lot of math this unit, but we did have a couple different mathematical pieces. Nernst equation, if you need that, it'll be on there for you so that you can kind of use that. I did not expect you to memorize that Nernst equation. I'll make sure I get it right this time. I think there was a typo on the quiz that I didn't catch. Good thing the quiz wasn't 4 points. Being able to solve for equilibrium constant for our K, solving for our cell potential. I guess I should put little dots in there. Little dots. Solve for standard cell potential using our Appendix D or our cell potentials for half reactions. Solving and changing that into our free energy. And then this was kind of the new piece that we learned digitally was that plating. If you were trying to figure out how long it would take those grams to go. If it's basic, no, I bet it's not going to be basic if you're writing cell notation. If it was basic, then yeah, you would include the hydroxides. Sorry, this is a question for Kendall, and ditto for Matt. I would not expect. I don't know if I've never seen one where I've had to write the hydroxides in there, so I bet it's not on there. And then plating, being able to go from grams to coulombs and then coulombs to time, or time back to grams. If a 12 amp current ran for 12 hours, how much plating, how many grams would plate out? And I believe there's some good ones for that on the study guide as well. And then golden oldies, always now more than ever as we start to approach our UMKC final and our AP exam, which is going to get modified. Still waiting to kind of see what UMKC does for my dual credit people. But golden oldies are still free game. Have big picture stuff, things like acid-base chemistry, the big strong versus weak stuff. Think about equilibrium and shifting. Le Chatelier, we did a lot of that. The other one, spoilers, your Q equals MC delta T. Yeah, big picture golden oldies, but there are some golden oldies on there that would be worth knowing. Cool. Questions coming here. Kind of a tech question for you guys. How is the frame rate and or stream quality coming your way? Trying something new. Gonna be a weird pause because I think there's a delay for YouTube between the live stream and then getting to yours. Okay. I know. Yeah, pros and cons. I can't see you guys, but it is good for us to make sure that we're kind of seamlessly getting you the info and you guys can still communicate via chat. I'll probably do a blend. These are good for the full review days, but if it's just general QA, I think Google Meet, we'll just keep trying stuff, see what we land on and what we like. spoilers, there might be a question built into this day where I'm going to actually elicit some of that feedback from you guys to kind of see what's working and what's not, because we're very much in as the district likes to say, we're in a fluid situation where things are changing quickly. And so we will continue to make this what works best for you guys. Cool. Any questions for the test and kind of what the rest of our week is going to look like? I know you guys have kind of been asking how it's going, but just wanted to give an opportunity for that today. If not, let's take a peek at the study guide. Obviously, I'm not going to be able to project the study guide without a projector. I've got a copy of the study guide here. We'll just kind of start working stuff as we want to look at stuff. And we'll just kind of start going from there. So if you got a question coming off the study guide, we are taking a peek. Unrelated to the study guide, is the UMKC final scheduled to be taken at school once we're back? Yep. And so if we do return on kind of I think the 24th is a Friday, we would return the following Monday. That would give us a week of review before the UMKC final would begin. So we would have a little bit of time kind of to make sure we get some of those review pieces and then be ready for that final. If we're not back, that's going to look a little different. We're still, we have gotten the green light from Doc Cramey, who's our curriculum coordinator, to assess at home. So it'll be some kind of blending of what we're kind of doing for this test. We'll continue to refine that and kind of figure out what works best. But if we have been given permission to test at home for the MKC final, if for some reason we aren't back by the start of May. I'm hoping we're back. It's just going to be a whole lot easier to be able to take questions real time and be able to work without the kind of the delay piece that we're seeing right now. So, cool. Kendall, what do we need to know about the equation with work? We did not actually calculate with work. It's just good to bring that relationship back in as we think about heat transfer and all this still being energy and useful energy and work. I would not expect you to be able to solve with work. So if you're able to go from, if you think of the triangle that we had, from delta G to K to E, if you've got that, should be good. And I believe most of those formulas are on your equation sheet, which we'll always be able to use as we're kind of working. I would not ask for a formula that's not either on your equation sheet or provided for you. Q1 on the answer key adds K's to the balanced equation. Yep, so that's just, so that's the one with the potassium permanganate, I believe. Yeah. Mine actually, I left them off. We did not practice it like that. And so I did not include those. Basically, the K's just get added to make it all the neutral compound of what would you actually pour in to the beaker to make the half reactions and to make the reactions go. But really, I would not expect you to do that. If you left them as ions, I'm going to be totally okay with that. Mm-hmm. Number 4 and 7. Number 4 being the is this the increasing and decreasing agents? That one, I believe, is number 4. Number 4, is the following reaction spontaneous as written? If not, write an equation for the spontaneous reaction, calculate E naught cell, and rank the 3 species in order of their decreasing strengths as a reducing agent. If you remember, the AP board said don't worry about agents, and so we're not doing anything with the agent part anymore, so we can kind of ignore that part. But really, this one's kind of weird to think about because we actually have 2 different things going here. We've got some irons. Don't worry, the windows needed to get washed anyway. We got some irons going from, going from 2+ to neutral iron. To do that, I think this is going to have to gain some electrons to make this species. And then we got some of those irons that are losing some of these electrons to change into our Fe3+. And to do that, it's going to have to lose 1 electron, I think. Yeah. And so it's weird to think about that. We're doing both simultaneously. If you can't read something, let me know. hopefully it's coming through legibly enough. If not, I can pull the whiteboard back up. I thought this would be easier for transition's sake. If we were then going to combine them, so we'll write a equation for the spontaneous reaction. Cool, so we need to find some standard cell potentials. For this one, I think comes up to negative 0.44 volts. For this one, I think we end up getting, ooh, is this on the wrong side? Oh, okay. I think if you look on the table and then flip it, going to be a positive 0.77 volts in terms of our standard cell potentials. And so then if we want kind of our overall equation, if we were to add these together, these would come out to be a positive, I believe. Wait, what do we got going here? Sorry, so I've got, 1 second. So I'll make sure I got my sign conventions correct here so I'm not confusing the matter. So I think as we got it here, if we try to combine them as we got them, I don't think this comes out to be spontaneous. I need my standard cell. I guess for my overall, I end up with my 2 iron 3 pluses reacting with Fe, because if I got 2 electrons here and 1 electron here, I'm going to have to multiply this all by 2 here, and then my 2 electrons are going to cancel. I've got an Fe plus and 2 Fe2 pluses. This would give us this original reaction, yeah, that we had for the overall. Sorry, let me get my eraser. Our 2 electrons would cancel. We'd be left with our 3 Fe3 plus going to an Fe and 2 Fe3 pluses. But I think I've got it such that I think I haven't flipped this yet as we're looking at our cell potentials, because I believe when we flip that as written here, this would come up to a negative 1.21 volts. So I just make sure I got my values correct, which would not be spontaneous. And so to write it spontaneously, we would flip it all, and then that would just change that to be then a positive value is what we'd end up seeing there. Yeah. Yep. Cool. 4. We also had 7 and 2. 4, 7, 2. Seven is the aluminum bromide and potassium fluoride. Determine the electrode products and write the overall cell reaction. Cool. So this is an electrolytic reaction. I'm just thinking about I threw all this stuff in and then we melted it, so it all kind of split apart into its ions. I've got aluminum 3 plus and some bromides, Br minus, split apart from the first compound. And then I've got some potassiums and some fluoride split apart in the second one. So if I'm thinking about what these are going to try to turn into, if I shoot a bunch of extra electrons in there or pull electrons out, aluminum 3 plus is going to try to gain 3 electrons, change into solid aluminum. It's going to try to plate out at, reduction is the gaining of electrons, so that would be at the cathode. Here we've got plus 1 electron, change back into solid potassium, which as an alkali metal explodes with water. Our bromide is going to try to lose some electrons to turn into bromine. The problem is that's diatomic, so there'll be 2 of those. To do that, I'd have to have 2 here and 2 electrons. Fluoride would then do the same and try to lose an electron to turn into F. Neutral fluorine, problem is that's diatomic, so again, we see a doubling of these. Cool. A couple different ways we can approach this. One is just in terms of kind of, we're thinking about what we're doing here is we're slowly increasing. So follow up on number 4, don't have to worry about the reducing strengths. We're not doing any of the agents like that. So as we're looking at these 4, a couple different ways you can think about it. You can think about it in terms of stability, or you could think about it in terms of their cell potentials. So if we look on the table for this reducing potential, we got negative 1.66 volts. Here we've got negative 2.93 volts. Here we've got our 1.07 volts, and here we've got our 0.741 volt. Nope, that's not right. Wrong number. 2.87 volts. Did I get that one right? Yeah, okay. Cool. So essentially what we're doing is we're taking an external power source, and we're slowly increasing the volts. We're increasing so we would start to increase the voltage until we get to 1.66 volts. Then the aluminum comes out. If we get it all the way up to 2.93 volts, then the potassium comes out. The negative sign here just tells us that this is kind of non-favorable. They'd rather stay as their ions. But if we put this much positive voltage in, it'll turn back. Well, we hit 1.66 before we get to our, follow-up question here. Do we still have to flip the signs for the bromine and the fluorine? You could. I think ultimately we're looking at absolute zero or absolute value in terms of kind of the voltages. So once we hit 1.66 volts, the aluminum's going to plate out. And actually, we start plating out the bromine first, because once we hit 1.07 volts, the bromine starts to come out. But yes, technically speaking, because we flip these to be oxidation reactions, these would then flip signs as well in terms of our reaction. But we're not adding anything here. We're really just saying what's going to plate out first and where. And so those would be the first two to plate out. So here's our anode. Here's our cathode. In terms of our cell notation, we go low to high, high to low. So it's going to be our Br minus in its liquid form. And it's going to bromine also in its liquid, because bromine's liquid at room temperature, one of those weird little questions. And then we would not actually have overall cell notation. Yes, cell reaction. Sorry, not cell notation. That's going on at the anode. And then at the cathode, we'd have kind of our low to high, high to low, our aluminum 3+ going back into our solid aluminum. So if we were to write our reaction overall, I think we'd have our, if we were to combine these two, right? Ooh, we've got 3 electrons, 2 electrons. Multiply this by 3. Nope, multiply this by 3, multiply this one by 2. So we would end up with 6 electrons, 6 electrons. So we're going to have 6 Br minus plus 2 Al 3+. Sorry, still visible. Yep, cool. Sorry, glare is a little less ideal. Turning into 2 Als plus our 3 Br2s. This is liquid. This is going to be liquid because we were molten. This then comes out as a solid, and this stays as a liquid overall. Glare's not great. Glare is not great. So was 7. Other one we had was number 2, I believe we wanted to look at. Right? Sorry, I lost in the chat. Yeah, 2. Number 2. So this is the potassium dichromate and our chromium in one compartment. We got tin and tin ions in the other compartment for number 2. Where to put my eraser? My high-tech quality eraser. Oh, neighbor's out mowing. Number 2. So if you're thinking about just what we're kind of got floating around in our beakers, really we've got kind of 2 sets of substances. We've got kind of our potassium dichromate, which, when we put that into solution, potassium is always soluble. So really that's split apart into our Cr2O7 2- species. And also in that same beaker, we've got chromium 3 nitrate. Well, nitrates are always soluble, so we also have our chromium 3+ ion floating around in there. So here's kind of the 2 aqueous species floating around in one of our containers here. If we're thinking about what's going on here, we've got a 3+ on this oxidation value. We've got 7 oxygens, a 2- on this oxidation state, unless it's a peroxide, so that's 14-. I want 2- left over, so I got to cancel the 12 positives. That means each chromium is a 6+. I'm just looking at my oxidation states. Looks like I got a chromium 07 2- to get from 6+ to 3+. I think we got to gain some electrons, right? So plus, in this case, 3 electrons, change into chromium 3+. We could go through and balance everything with our stuffs, but I don't think quite there yet. You could also cheat, I think, and if you look on Appendix D, it actually kind of balances this half reaction for you. That's neat. We would have to do some stuff with some oxygens here and some waters. We'll come back here in just a second once we kind of got our parts figured out. Looks like we've got that going on for that one. And then for our other kind of container, we've got a solid tin in there. And then we've got some tin ions floating around in solution, in this case, tin 2+, because again, the nitrates break off, and now we've got our tin floating around in solution. Cool. All right, so I guess if we're thinking about that one, if we're just thinking about our kind of reduction potential, we have Sn 2+, reduction is the gaining of electrons plus 2 electrons, change back into our tin metal. So I think these are 2 kind of reduction potentials if we're thinking about which of these is going to set us up for a spontaneous reaction. Spontaneous reaction, we would need some cell potentials, which I don't have listed because I am a scrub. Un momento, por favor. So for our tin 2+, going to solid tin, we've got, looks like negative. And for our dichromate, probably with some acid. It was the weirdest stream I've ever seen. There it is. Looks like I got a positive 1.33. Well, so Olivia's jumping ahead of us just a little bit in terms of our sign conventions here. We're used to running it left to right, anode to cathode. But if we're looking at our voltages here, in order to have it positive and we add the 2 together, I think we're going to have to flip this one, yes? So that this would change into a positive value. So we're going to have Sn actually releasing those 2 electrons and forming our Sn2+. This is a loss of electrons. So this is actually our oxidation reaction. This becomes a positive 0.14 volts. As a result, it's our anode. So yes, if we're going to do our standard convention where we go left to right, we now know which one it was. We could have done the arrows the other way, but if we want to be our normal convention, we can do that. Got Sn, our Sn2+. Just haven't quite figured out which of our 2 is going to be our oxidation yet. Cool, and then I think we got to do a little work here in terms of getting our overall balanced equation. Yeah, that's a good review. Can I? Oh, yeah, perfect. I'm going to sneak over here just so I can balance this half reaction real quick. Again, you can kind of cheat and pull it off your sheet if you needed to, but I think it's going to be good practice for us. Chromium 3+. I've got 7 oxygens here, so I'm going to have to add 7 waters over here. If I got 7 times 2 hydrogen, that means I'm going to need 14 positives over here. If I'm taking a look, then how am I coming up? I got 2 chromiums here, so I'm going to need 2 here. And if each chromium is is gaining 3 electrons, and I have 2 of them, I'm going to need 6 electrons here. Ooh, okay. we double check? I've got my reactant side, I got 14 positives, 8 negatives. 14 minus 8 is 6 positives left over. We have 2 times 3 plus, so 6 positives here. I think those are half reaction, which is confirmed on Appendix D. Hopefully you guys can read that still. So here's our half reaction here. A couple things to note. Oops, should have my H's in there. We got 14 hydrogen, so this does need to be acidic, which I believe most of our half reactions are written as an acidic solution. And so our tin is going to lose its electrons. It's being oxidized at the anode. Oxidized at the anode and sending it over to our other beaker. Problem. State symbols. Aqueous. 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 This is the dawning of the age of aqueous. Sorry. We got no solids. So we're going to need some graphite or some platinum. However you want to do that. Player's choice. You feeling rich? We can do platinum. Sure, why not? Cool. And then we'd have over here floating around to make this work. We need some acid. We need some of our dichromate and our chromium 3 plus all floating around in that other beaker. So balance equation, we've got 6 electrons being liberated here. We're only picking up 2 here, so I think we're going to need to multiply it by 3. Turns into 3 tins going to 6 electrons and 3 of our tin 2 plus ions. Once we got our 2 electron counts to be the same, we can then go ahead and add them together real quick. Looks like our electrons are going to cancel out. And I'm going to have 3 tins. I'm going to be lazy here and sneak them in. And then we're going to get 3 of our tin ions coming out over here. For our overall balance equation for spontaneous reaction. To get our voltage, we would add these 2 values together. Oh, didn't ask for the voltage, did it? Oh, and it even told you it was negative relative to graphite. Oh, fine. It told you graphite. Fine. Lame. That's carbon. Cool. So low to high, high to low. We start with the anode. Our low value was the tin. Going to our tin 3 plus, 2 plus, 2 plus, 2 plus, aqueous in solution. And then on the right-hand side, we've got our high oxidation state, which was our Cr2O7, or 2 minus, changing it into our Cr3 plus. Low to high, high to low. Both these are aqueous. We did need some acid in there, and we needed some carbon in there. This was aqueous, and this was solid. The only thing that's missing then for my cell notation, because it asked us to diagram the cell, we would still need a salt bridge. Without the salt bridge, this doesn't work. Oh, that was a bad salt bridge. Cell, we would still need a salt bridge. Without the salt bridge, this doesn't work. Oh, that was a bad salt bridge. For our final cell notation. That's a good question. Cool. What else? I think I got them all. Am I missing any? I could cut up. Oh, we lost people on the stream. People had to go. If you're looking for additional practice problems, any other textbooks that are blue are good ones with the answers provided. Not a bad way to confirm whether or not you're doing them correctly. Happy to take questions, as always, via email as we're kind of gearing up for our assessment. You guys are doing great, truly and honestly. Keep on plucking away. We're really quickly coming into the end here. Once lecture chem's done, we kind of switch gears to organic. We won't be doing any more math. We'll kind of just be looking at some of those organic properties and organic molecules. So cool. If you have any last minute questions, feel free to shoot me an email and I will send one on back. If I want to if it helps, I might make a quick video and shoot it back that way. And if schedules allow, we can always meet on Google Meet as well. Thanks everybody for stopping by. Good luck on the assessment tomorrow. If something were to happen, shoot me an email. Later.